Okay, so welcome to this quick review series. In this one, we're going to do a review of radicals. So FYI, I designed this review series to help you review maybe for like a math placement exam. So you can use it also as a quick review if you forgot this topic for some math class. Sometimes I refer to a specific math placement exam. That would be the ALEKS placement exam. So if that doesn't apply to you, you can just ignore that. Okay, so let's just review radicals for a second. So first things first, something that people often forget about with square roots. So if I ask what are all the square roots of 9? So what does that mean? What are we looking for? Specifically, we are really asking what times what equals 9. That's what it means to be the square of something. So what can I multiply together twice, 2 times, to get 9? Well, there's 2 answers actually. 3 times 3 will equal 9, but also negative 3 times negative 3 equals 9. And this is an important thing to note because there are times where knowing that there are negative versions of the square root matters. So it's just something that you want to keep in mind. So this is the square root notation. And okay, so the thing about the square root notation is that it actually takes care of this problem of, oh, there's a positive one and a negative one. So the square root notation means that we only want the positive root. So if we wanted the negative root, what we would have to do is put a negative straight up in front, like you see here. So that's how you know that you want the negative root. So it's actually nice and clear. Now, what are all the cube roots of 27? Well, that's saying what times what equals 27. And so when you're multiplying 3 things together, you have to think about this for a second. But 3 times 3 times 3 is the only way to make 27. Sometimes when people hear this, they want to say, oh, but what about negative 3 times negative 3 times negative 3? Okay, negative times a negative is a positive, and then times another negative, this would be negative 27, right? So this one won't work. So for cube roots, there's actually only the 1, and so we don't run into this problem. But there are negative cube roots that exist. So the notation for a cube root looks like this. So it looks like a square root except it has a 3 here. And really anything bigger than a square root can be represented this way. We call them nth roots. And so you can put whatever number you want here. And so what this means is what can you multiply together n times to get the number that is down here? So I want to just also mention, so the square root is the only radical that does not have that little number in the corner. So if you don't see one, then you know it's a square root. We just automatically assume that. And it would be weird to put the 2 there, so we just don't do it. Now, one other thing I guess I want to note is that for this video, so we're going to say that for even roots, like square roots, 4th roots, and 6th roots, so if the number underneath these is negative, these do not exist. You can't evaluate these for negative numbers. Now, some of you might be saying, but what about imaginary numbers? So for square roots only, it is possible to have imaginary numbers. So for instance, the square root of negative 4 would be 2i, or the square root of negative 25 would be 5i. So if you don't remember this, this is another topic entirely that I'm not going to cover in this video because it would make this video very long. So I'm just not covering imaginary numbers in this video, but maybe in the future I will do that. So if you are interested in seeing an imaginary numbers review video, leave me a comment and I'll totally make one. Okay, so just to summarize, square root of negative 9, 4th root of negative 16, 6th root of negative 1. So for right now, all of these do not exist, at least right now for this video. Now, some of you probably know this one does exist, but these 2 still do not exist. Okay, so that's like kind of the key thing that we got to remember. Now, what about for odd roots? So what about the cube root of 125? So what can I multiply together 3 times to get negative 125? Well, I can multiply negative 5 times negative 5 times negative 5. That'll totally get me negative 125. So odd roots of negative numbers exist. What about for the 5th root of negative 32? You can pause the video if you want to think about it. In fact, I would recommend that. So this will equal negative 2. Okay, cool. So let's just see how well you remember some of your just basic roots. So I've got this list here. So pause here for a second. Think about these 4. Remember, math is not a spectator sport. Like, you'll get more out of this video if you actually pause and try it. So I recommend you pause here, and then I'll go through the answers. Okay, so the square root of 25 is 5. So notice here, I have this negative on the outside of 16. So this is specifically calling for the negative square root of 16. So this equals -4. The cube root of 27 is 3. And the cube root of -27 is -3. Okay. And just notice, right, it's fine if the negative falls outside of the square root. If it fell inside of this, let's say that again. It's fine if the negative falls outside of the square root. When it falls inside, that's the problem. Okay, so next we're going to talk about how to break down radicals, how to simplify them. So something that's super essential if you're trying to review radicals is you must know your basic squares, cubes, etc. This is vital, and I have a handy little chart here for you. So if you have trouble remembering these, one thing that I recommend is that if you're in a situation where you've got to simplify this kind of stuff, force yourself to just write this chart down. I have found sometimes with some students that they are just, some people are just visual when it comes to this material, and they do a lot better when they have the chart in front of them. And so if you are in a situation where you need to start suddenly breaking this down a bunch and you struggle with this, this is the chart that you should have memorized and you should just feel like you can write down. So you just really need to square 1 through 12. So if you know your squares, you can just figure this chart out. And then you need to cube 1 through 5 and 10. And then very often 2 to the 4th, 2 to the 5th, 2 to the 6th are handy, 3 to the 4th is handy, and then 10 to the 3rd is handy. So these I think are the most popular squares, cubes, 4th powers. These are the most popular that I typically see. Possible that you could have others, but these tend to be the really common ones that I notice, especially for like a test like ALEKS. Okay, so now let's talk about how do I simplify things then that are not perfect squares. So square root of 12 is not a perfect square. So what is a perfect square? When we talk about a perfect square, that would be 25, right? So it would be something that falls in our table. So 5 squared is 25, so we call it a perfect square. So 12 is not a perfect square, so what do I do? Well, what I can do is I can break down a radical using a special property of radicals. Now, the thing that I want to do is I want to think about the squares, the perfect squares that divide into 12. So if I go to this chart and I just focus on the squares, what is the largest perfect square that divides into 12? And by the way, what you're looking for is this part of the column here. So which one of these numbers divides into 12? That would be 4. So 12 can be rewritten as 4 times 3. And then we are allowed to break up a radical by multiplication. So I can break it up like this. And so now you can see which part of the radical you can evaluate. The square root of 4 is 2, so this becomes 2 times the square root of 3. That would be how you simplify that radical. Now, if we contrast that to the cube root of 3, it's the same idea, except now I'm not talking about squares. Now I'm talking about cubes. And again, I'm thinking in this column here. So what's the largest number that divides into 24? That would be 8. So I will break this down into the cube root of 8 times 3. So this is the cube root of 8 times the cube root of 3. And so then the cube root of 8 is 2. I can't do anything with the cube root of 3, so we'll just leave it at that. Okay, so it is at this moment, by the way, that I'd like to mention that I have free PDFs of the notes on this video, plus all these problems that you see me going through. I have it all like written down in a PDF. In general, I think that you're more likely to remember this material if you write it down. So I have these really nice PDFs just so you can follow along with the video. If you're interested, go to divideandconquermath.com, go to the review section. You can look for this topic. All of it is free. Okay, so let's keep going. I want you to pause the video now and try these two, especially if you're trying to review this topic. So try these two, hit play when you think you've got it. Like I said, math is not a spectator sport. You'll get a lot more out of this if you actually pause and try. So the largest perfect square that goes into 50, so again, I'm looking at this column here. So 25 is the largest perfect square that divides into 50. So I can rewrite this as 25 times 2. And so I can break this down as the square root of 25 times the square root of 2. And so this will equal 5 times the square root of 2. If I do this again for the cube root of negative 32, so once again, the largest perfect square that, the largest cube that goes into 32 would still be 8. So I can, I can rewrite this as the cube root of negative 8, we'll make this negative now, times the cube root of 4. So this will equal negative 2 times the cube root of 4. So if it's negative, you just want to get in the habit of bringing that negative on the outside. Okay, so I do want to just mention at this point that I'm going to kind of pivot here, but you can practice more of this type of skill in my first set of practice problems. So all of my review videos also come with free practice problems. So I'm going to keep going with this review, but if you feel like you need to practice this more, you can actually pause here and go and practice a little bit and then come back. It's up to you. Because now what I'm going to talk about is radicals with variables. So I'm going to keep going. So now I want to talk about what do we do when I have numbers and letters under the radical. Well, these are actually pretty nice situations to start with anyways. So the square root of 25, we know how to evaluate that, right? So the square root of 25 is 5. So what do you do with these exponents here? Well, you divide them by whatever radical you have. So in this case, remember, there is an invisible number 2 here. So what you're going to do is you're going to divide each one of these exponents just by 2. That's it. So if I take 6 divided by 2, that would be 3. If I take 10 divided by 2, that'd be 5. And then 4 divided by 2 is 2. And so this would be your answer. 5x cubed y to the 5th z squared. Okay, so why don't you try that for the next one just to see if you've got it. Hit play when you're ready. Okay, so this one, so the cube root of 8 is 2. And then I can divide all of these exponents by 3. So this will be x squared, y to the 4th, z to the 8th. Cool. All right, so I have 2 more of these just to make sure. You got to be super solid on this before I start throwing some of the crazier stuff at you. So I get 2 more just to make sure you're good, and then we're going to keep going. So again, pause. Let's just make sure you're solid on this, and then we'll keep going. Okay, so this is going to equal 3xy to the 4th z squared, and this next one will be 5x squared y to the 5th z. Okay, cool. So now what I want to do is, of course, I want to change it up. So now I have the square root of x to the 7th. So the obvious issue here, right, is, so this is a square root. 7 cannot be evenly divided by 2. But now we can employ a very similar strategy to what we did earlier. So what I'm going to do is I'm going to think of what is the largest number just below 7 that 2 will evenly divide. So there's actually 2 ways to do this. So let's see, I'll show you way 1 and way 2. So let's start with way 1, and then we'll talk about way 2. Okay, so starting with way 1, so the largest number just below 7 that can be evenly divided by 2 is 6. So one way that I can handle this is I can think of this as x to the 6 times x. So I'm just using exponent properties here to break up x to the 7th. But in doing this, now what I can do is I can rewrite this as x to the 6 times the square root of x. And so this is x cubed times the square root of x. So this is one way to do this. And I think that this is nice and intuitive given how we've already approached radicals. Now, there is another way, though, that you can do this just using the division algorithm, so thinking about remainders and whatnot. So the other way that you can handle this is, so you can think to yourself, first of all, you know that there's going to be an x under the radical because 2 does not evenly divide this. So it's like you know that there's going to be a remainder. So if you know that there's going to be a remainder, you can set an x here and an x here, and then we're going to do the division. How many times does 2 go into 7? It goes into 7 3 times. And what is the remainder then? 1. This is the other way that you can evaluate these types of problems. So it's how many times does 2 go into 7? 3 times with a remainder of 1. This will get you to the exact same answer. Now, sometimes people like to start with this until they feel confident, and then they kind of switch into the other method. So it's up to you which way you want to do this. I'm going to show you both ways. I'll do it again for B. Okay, so now I've got the square root of x to the 9th and y to the 9th. Okay, so if I want to do this with way 1, so I'm going to think about this as what are the largest numbers below 9 and 13 that are divisible by 2? So that would be x to the 8th and y to the 12th. So again, notice how I've kind of strategically broken this up. So I've got 8 and 1, 12 and 1, and those still add up to this. And so now what I can do is I can break out the parts that can be evenly divided by 2. So I'm going to put x to the 8th and y to the 12th here. And then I'm going to put xy under its own radical. And then I can rewrite this as x to the 4th, y to the 6th times the square root of xy. Okay, so there's one way that you can do this. Now let's talk about way 2. So looking at this, I see that 2 will not evenly divide 9 and 13. So right away I know that there's going to be a remainder. So what I like to do is I like to kind of set up everything so that I can do the division. So I know that there's going to be a remainder of x and y, so I'm just going to put an x and a y here. And now I'm going to do my division. How many times does 2 go into 9 evenly? It goes in 4 times, and it has a remainder of 1. Okay, so there's my x. How many times does 2 evenly go into 13? It evenly goes into 13 6 times with a remainder of 1. So you see, it gets you to the exact same thing. But again, it's kind of a matter of confidence and just kind of how your brain works. Some people really like having the visual cues, and that's totally fine. So I just wanted to show you both ways. So I've got 2 more here. These are with cube roots. So I'm going to actually just turn you loose on this. I'm going to suggest that you pause here and try both just to see how you're understanding it. Hit play when you're ready. Okay, so I'm going to do this one more time using way 1. So the largest number below 8 that's divisible by 3. So in this case, if I want to do this via way 1, this is going to be x to the 6th and x squared. So 6 and 2 make 8. And so then I can rewrite this as the cube root of x to the 6th times the cube root of x squared. And so this becomes x squared times the cube root of x squared. Versus if I want to do way 2, so I can see that there's going to be a remainder. So I'm going to just kind of set this up so that I can just start the division. So 3 goes into 8 2 times and then has a remainder of 2. Same and the same, right? Okay, so I'm going to use that now with D here just to kind of speed things up now. So once again, I can tell that I'm definitely going to have a remainder. So how many times does 3 evenly go into 14? 3 will go into 14 4 times. 3 times 4 is 12. 14 minus 12 will leave you a remainder of 2. So there you go. There are the 2 ways. So if you're still following along, if you are enjoying this video, please consider hitting the like button, commenting with any suggestions, or subscribing to the channel. I'm going to keep going with examples like this now and just kind of ratcheting up the difficulty for the rest of the video. Okay, so now what we're going to do is we're going to kind of put everything together. So just to review what we've done so far, I've got A and B here. Once again, I'm going to recommend that you pause here, give them a try, hit play when you're ready. So these 2 are nice and straightforward examples because there's no like remainders, there's no like breaking anything down. So the square root of 4 is 2, and then if I just divide x to the 6th and y to the 10th by 2, this is going to leave me with x to the 3rd and y to the 5th. So that one is a nice one. And so is B, so the cube root of 27 is 3. And then dividing each exponent by, so remember we're doing a cube root, so I have to divide each exponent by 3 now. This is going to give me x squared, y to the 3rd, z to the 5th. Okay, and so now we're going to start getting into the more difficult parts of this. Now we have to start keeping track of information. This is kind of a lot to throw into one problem. It looks simple, but it can start to get deceptively tricky. So I'm taking a look at this radical. I've got the square root of 12, x to the 6, y to the 10th. So which part of this will not be broken down nicely? It's this square root of 12, right? So now you have to make some decisions and you have to think about how your brain works. So some people will choose kind of the part of the radical that's going to be the tricky part, and they will evaluate that part separately. So I'll just show you kind of what I mean. So some people will take the square root of 12. They know that that's not going to break down nicely. So they do the work and they get that this is 2 times the square root of 3. We already went through that. But they go through and they figure that part out. And then I've got 2, and these 2 parts here will work out nicely. So I can just then say this will be 2 x to the 3rd, y to the 5th, and then I know I've got that radical, that cube, that square root of 3. So this is one way that you can do this. Another way, I'll just show you another way. Like I said, this kind of just becomes a challenge now in organizing information and deciding how it's best for you. Everybody's a little different in how they like to organize this. So another way to do this would be to think about this in terms of what can you break down versus what can't you break down. So when I look at this, I think of 12 as being 4 times 3. When I'm doing square roots, that's just kind of where my brain goes. So what I like to do is I like to write out the part that I can actually evaluate. So 4x to the 6, y to the 10th, times the parts that I can't. So that would be the square root of 3. So all of this part here, I can easily evaluate. So this becomes 2x to the 3rd, y to the 5th, square root of 3. So there's 2 different ways that you can kind of do this. Now, I have a tendency to gravitate towards this part here, but you know, everybody's a little different, so I just want to show you different ways to think about it so that you can do what's right for you. So let's try this one more time with D, and then I'll let you practice some. So for this one, I am going to break this up into, so the largest cube that goes into 16 is 8. And then x to the 6 and x to the 6 can be easily broken down. Y to the 10th will not be fully broken down, right? 3 does not divide into 10. So another way that I could do this is I could separate this as to y to the 9th. And then look at how I kind of break this up. This is 2 and y. Okay, so just appreciate kind of how I decided to break this up. 8 times 2 is 16. X to the 6 we already said can be broken down, so that goes here. And then y to the 10th can't be fully broken down. So instead I take out the part that I know I can break down, and then I kind of leave that remainder. So these are the parts that can't be broken down. So with that in mind, this will equal 2x squared y to the 3rd times the cube root of 2y. Okay, so let's start ratcheting up the difficulty of this. So I've got E and F here. So again, I would recommend that maybe you just pause here, give these 2 a try, hit play when you think you've got it. So I'm going to continue on with this method of just showing you what part can be broken down. So the largest perfect square that goes into 50 is 25. X to the 6, that will divide out perfectly. And then y to the 6 will also divide out perfectly. So what's left over here? 2 and y. And if I just do a double check real quick, 2 times 25 is 50. We're all good. And then y to the 6 times y will give me y to the 7th. So I'm just using my exponent rules to do that. And so this will equal 5x cubed, y cubed times the square root of 2y. And then moving on to f here. So if I break this up, I've got 125 is the largest perfect cube that goes into 250. I'll have x to the 6 and y to the 12th. So these are the parts that I can break down versus the parts that I can't. So 2 times 125 is 250, and then I'm going to have x squared and y. So again, I'm just going to count to make sure that this all multiplies back. 125 times 2 is 250, x to the 6, x squared, yep, that'll get me x to the 8th, y to the 12th, and y, yep, that gets me y to the 13th, so I'm all good. So this is going to be 5x squared, y to the 4th, so that's dividing the exponents, and then here's the stuff that I can't do anything with. Okay, cool. So the key thing here is that when you've broken this down, the the remainders here, these numbers, these exponents, need to be smaller than this index. That's like one of the key things that you're looking for to make sure that you actually broke this down right. So for instance, just to show you like an issue, if I had like x to the 7th, or sorry, if I had 2x squared y to the 7th, so just hypothetically, if this was what I left as my remainder, 7 is larger than 3, that would be a problem. And that would tell me that I didn't break it down far enough, if that makes sense. Okay, so I've got just a couple more here, same idea, and then we'll try a couple of fourth roots, and then that'll be it for this video. And if you want to do more practice, you can. So why don't you pause here? Let's just make sure that you're getting this. Pause, hit play when you're ready. Okay, so for this one, wrong color. Okay, so the largest perfect square that goes into 24 is 4. And then I can write x to the 6th and y to the 10th. So the stuff that's going to get left behind is going to be 6xy. Okay, so this will be 2x cubed, y to the 5th, times the square root of 6xy. So that's all she wrote for that one. Now for h, we're doing the exact same problem, but now we're doing it as a cube root. So in this case, the largest cube that goes into 24 is 8. Then I can leave this as x to the 6th and y to the 9th. And what gets left as a remainder is 3xy squared. So 3 times 8 is 24. 6 plus 1 is 7. 9 plus 2 is 11. So we're all good. So this is going to equal 2x squared y to the 3rd times the cube root of 3xy squared. And the last two, so I just wanted to switch it up. We haven't done anything with fourth roots, but it really works the same. So you might want to just reference your little chart here. I can pause this if you want to take a look at it. Pause now. But otherwise, I am going to leave these last two for you to give a try. So hit play when you think you've got it. Okay, so the largest fourth root that divides into 32 is going to be 16. So this is going to be the fourth root of 16. And then if I break down these other pieces, so x to the 4th can be broken down, y to the 12th can be broken down, and z to the 16th can be broken down. So the stuff that's going to be left over is going to be 2x cubed and y squared. And again, if I just double check to make sure these all add up, 4 plus 3 is 7, y to the 12th will break down, 16 plus 2 is 18, and 16 times 2 is 32. So we're all good on all of this. So this is going to be 2x, y cubed, z to the 4th, times the 4th root of 2x cubed, z squared. Oh, I'm sorry, I think I wrote a y there. I meant to write a z. My bad. Okay, cool. And for this last one, so I've got this 4th root of 16x to the 10th, y to the 13th. So in this case, the 4th root of 16 will break down. X to the 8th can be broken down, and y to the 12th can be broken down. So my remainders are going to be x squared and y. So this is going to be 2x squared y to the 3rd times the 4th root of x squared y. Okay, and so on that note, you can't master math just by watching a ton of YouTube videos. You do have to practice it. So like I mentioned earlier, my review videos have a companion additional practice problem set. This video actually comes with 2 different sets of practice problems. One are like more basic, and then the other are harder ones, like how we ended the video. So if you want to check out these additional practice problems, I have a PDF of the problems, an answer key, and then also a video showing you how to work out the solutions. So if you're trying to make sure that you really remember this topic, I would recommend that you check this out next. It's all free. Go to divideandconquermath.com and then just go to the review section. And my review series has many other topics in it, by the way. Each video works just like this. There's a refresher video like the one you just watched. Then there's practice problems with the answer key and worked out solutions. So I have lots and lots of topics, and I'm planning to add more. And if you have requests for them, you can even just leave a comment. So all of this can be found at divideandconquermath.com. Just look for the review section and you'll find everything for free. Okay, and on that note, I am going to end the video here. I'll talk to you guys later. Bye.